So we just finished explaining how this formula or how this procedure works. And here's a formula. Notice this formula says put p hat at its center. Then I'm going to use a number of standard deviations. And notice it's called z star. We'll talk about it in a second. And here's my standard deviation. Again, notice I mentioned before that we're not going to use sigma p hat. We're going to use another standard deviation that is an approximation. So the best I can do is I don't know what this is, so I approximate it with p hat. I do not know what this is, so I approximate it with whatever this is, which you can see right here. This is the formula. And what I've done is replace p with p hat. I'm assuming that I meet this condition. Binomial language we haven't talked about, so let's disregard that. And again, study this carefully. It's not enough to just use this formula. You must be acquainted with the components of this formula and what they indicate. So let's talk about the components of this formula and what they indicate. So before I do that, I'm going to just one more time emphasize what this formula is. Here's p hat, and then I'm going to add. So this upper end is going to be p hat plus whatever value I decide, the number of standard deviations I decide that I want to use. On this other end, it's going to be p hat minus this value. And that's again how the visual of this range estimate. This value, as you're going to see later, is how wide it determines, well, it will determine this number right here, the likelihood of success. Components of this formula. Let's talk about this. What is the standard error? How does it differ from the standard deviation? Standard error, often abbreviated like this. Standard error of p hat, specifically because we're talking about p hat. What is this? Standard error is an approximation of standard deviation, in this case of p hat. But in general, standard error is just an approximation of standard deviation, whatever it happens to be. So that's all the standard error is. And you can see from the formula, in this case for p hat, that we have two different values. Standard error is p hat, 1 minus p hat, divided by n. As standard deviation is of p hat, it uses the actual parameter, p, 1 minus p, divided by n. So obviously we cannot use this one because I just don't know what it is, and that's the whole purpose of this. Sorry, I'm off screen. That is the whole purpose. I don't know what this value is. What is the confidence level? All right, so what is the confidence level? The probability that a range estimate will contain the parameter we're trying to estimate. That's all it is. What is z star, and is it different from z? Both z star and z are, well, z stars. So that part is exactly the same. So why do they have a little star here and no little star before? And the answer is because this usually comes from data. And this one will not come from data. This does not come from data. It is user picked. I mean, in other words, I pick it. I might decide to use 2. I might decide to use 1.96. I might decide to use 2.455. So whatever. I pick this. That's the difference. you have to pick this value to achieve a certain goal. This one, before only been using before, comes from the data. That's the difference. What is the margin of error? So I'm sure you've heard this before, the margin of error, margin of error. What is the margin of error? So the margin of error, sometimes abbreviated ME for margin of error, is the following. In other words, the margin of error is how many of these you're about to use, and of these means standard errors. So what we have here is times standard error. In this case of p hat, but it could be of any statistic. And often this is called the critical value. So this does not, again, it's going to come from data. Just note that Z star is often called the critical value. And in mathematics, the critical value is this cutoff. On one side of the critical value, something happens. On the other side of the critical value, something else happens. So right now, we're using this to create our interval, which is then what happens when we choose this value. Then we can figure out the confidence level. So Z star is used to determine the confidence level. So I'm going to write this down here. Z star is used to determine confidence level. And that's another thing you want to keep track of. There's different things. Standard error measures variability. This one, though, measures the likelihood that you're going to succeed, which is estimating, having a range of values that contain that parameter you're after. What is Z star value for 95% confidence interval? Well, I'm glad you asked. So if you wanted to find the 95% confidence interval, the Z star, here's what you want to think about. 95% means the middle 95%. And remember, we're going after the Z star. Put 0 here. And then, if that's the case, we recognize that this area to the left and to the right is just going to be 1 minus 0.95, which in this case is 0.05. If I take 0.05 divided by 2, I get 0.025, and that's this area right here. This is 0. So, to find this missing value, and then you might ask, wait a minute, isn't it supposed to be 2 standard deviations? The answer is, well, remember, the 2 standard deviations is an approximation. So in that case, I'm going to go here to GeoGebra. I don't care which side I use. I can use the left or the right. I'm going to choose the left. And then I'm going to type in the area that I want. The area that I want is 0.025. And now I get to see the Z-score, 1.96. So really, on this left side, it's going to be negative 1.96. And actually, there's a 0 afterwards. And that means because of the symmetry on the right, it's going to be positive 1.960. But of course, that is irrelevant because the formula is already taking this into account. When you look at the formula, there's a plus and a minus. So all you're going to do is write the positive Z star value. And then this formula takes care of adding and subtracting, which is what you get. This one's the negative side and this is this positive side, but it's the same value. So if that's the case, let's find the one for the 99% confidence interval. Using the same logic. I need to figure out what these 2 values are, but then I'm looking at the middle, 0.99. This leaves 1% on one side, so we're going to take that divided by 2. You got 0.005, and that's the endpoint. So I'm going to come over here and just type that in as my endpoint, 0.005. And again, I could have done above or below, it doesn't really matter. And I get this value. So for 99% confidence interval, Z star is going to be negative 2.57. You can see that's 5.8. I'm going to just use traditional, like you see at textbooks, 2.5, and then it's rounded to 3. So usually, I don't know why, but they just go 3 decimal places and call that good enough. So what's the value for a 70% confidence interval? Now, this is just here for illustrative purposes. The homework may ask you to do the same, just pick a value. And for illustrative purposes, so you make sure you understand where things are coming from. But the reality is, we are very limited on what we can choose for Z star. 95 is one of them. 99 is another one. There's one more that is normally used. And I always have those in a formula sheet. But again, it's nice to know where these numbers are coming from and what you're aware. That's really the important part. So it's not just some mystery. So again, what I have here is 0.70. So I go 1.70. That gives me 30%, the sum of either end. I take this, cut it in half, gives me 15%. So if I am looking for these two values, that mark the middle 70%, it will again enter the area that I want. And I see that Z star is negative 1.0364. Okay. Again, to those many decimal places. And that's how you find Z star, which is known as the critical value.